Thanks for the introduction, Christina. Good afternoon, everybody, and I'm very pleased to be here to be able to share with you some of the ideas about the future of water, and specifically about a new paradigm for wastewater management. Well, all of us, we know that water is popular, but how would you do it in order to measure the popularity of a concept, for example? Well, I thought searching on Google can be quite a good one, no? So then I type it on Google first, economical crisis, and then I type it sex, which is supposed to be quite a popular term in internet, and then my favorite team, Barça, and as you can see, water was the most popular by far. Actually, even more popular than Barça, can you imagine? So it was. So clearly water is popular, but most important, is essential for life. It's essential for all forms of life, for plants, animals, and human. In our case, it represents about 70% of our mass. We're lucky we have the same number like the previous presentation by Pere. In this next number, which is that also covers 70% of the Earth's surface. The problem is that only 3% of this water is fresh water, so really easily accessible by the human. Water is clearly very important for the world economy, so we better should manage this resource in a proper way. But how can we do it? We think we can do it adding intelligence into this empty head sometimes. And this is what is this talk about. The talk is focused on the use of knowledge for improving the water and wastewater management nowadays. So, but at this moment we should ask, where is located water? Well, you probably know this cycle. Water is not stagnant, but is in continuous movement through the natural water cycle. It's circulating through the atmosphere when it's evaporated, and then is circulating through groundwater and surface water after rainfall and runoff. However, today here, I'm more interested in the modification of the natural water cycle by the human activity, the so-called urban water cycle. It is also called anthropogenic water cycle or artificial water cycle sometimes. Within this cycle, water is extracted from nature. It is treated to different qualities for different uses. Then we use it at our houses, we use it in our crop fields, and we use it in agriculture. After the use, we collect it through the sewer systems, and we have to treat it again before being discharged to the nature, to be returned to the environment, or otherwise maybe to be reused in different applications. So when we use water, normally we contaminate it by the introduction of different substances or pollutants, and then we refer it to as wastewater. The most important pollutants are solids and organic matter, nutrients, and recently a large group of pollutants is gaining importance, the so-called priority and emerging pollutants, such as, for example, pharmaceuticals, personal care products, or drugs. And which is the current wastewater management approach? This is the current wastewater management approach. Actually, I would say not in India probably, because unfortunately, according to the United Nations, still 2.5 billion people is lacking of a proper sanitation. But let's concentrate, this is the wastewater management approach in the urbanized societies, or developed societies, let's say. It can be seen as an industrial activity where the raw material is the wastewater, then it is considered as a waste, which is transformed by different processes, then consuming chemicals and energy into treated water and byproducts, mainly solid waste and gas emissions. So we are producing also environmental and economical impacts. A new management paradigm would be, or is, to change our concept from wastewater to resource, and from wastewater treatment plant to resource recovery plant. Wastewater should not be considered anymore as a problem, as a waste, but on the contrary as a resource. Because not only from the point of view of the water quantity, but also in terms of its constituents. Because actually from wastewater we have the technology to be able to recover energy, to recover mass, treated water that can be reused, nutrients, and also chemicals, for example, some biofuels or bioplastics. So this is really the most trendy now wastewater vision at this moment. However, actually the most important idea that I would like to give you today is that from wastewater we are also able to recover knowledge. So we want to recover knowledge also from the management of wastewater. What type of knowledge? So knowledge related to all the design and operation of the urban wastewater systems. So we are interested in both successful and not so successful stories or lessons that we have learned in the operation of huge number of wastewater treatment systems that are being designed and operated all over the world. But how can we recover and use this knowledge? We think that we can use it, or we can do it by using environmental decision support systems. Environmental decision support systems can be defined as intelligent information and analysis systems which integrate mathematical, statistical, and artificial intelligence techniques to reduce the time in which decisions can be made, as well as to improve consistency and quality of these decisions. Besides, environmental decision support systems should take into account multiple criteria, such as, for example, technical, environmental, socioeconomical, or political criteria, when facing complex problems, such as the one at hand. So, environmental decision support systems actually are tools which are able to integrate mathematical and statistical models, which are useful for numerical calculations, and we need those here, but also together with artificial intelligence techniques, mainly knowledge-based systems. Among them, for example, case-based reasoning systems, rule-based systems are among the most well-known, because these systems are very adequate to include qualitative knowledge and heuristics, which is very important in this domain, as well as to provide self-learning capabilities and humankind reasoning. An example of a step forward to this new paradigm is the European project that is being coordinated at Lechia, at the University of Girona. This European project has as one of the main objectives to improve the design and operation of urban wastewater systems through the application of multi-criteria decision support tools. The innovative view of this project relies on the fact that we will consider for the first time the management of all the elements of the urban wastewater system, which are the sewer system, the plants, and the receiving media, the rivers, all together in the same way. Because until now, the management of these three elements have been always considered individually. This project involves 15 different partners, stakeholders, from 8 different countries, all of them related to the urban wastewater management. And there is experts there involved from research and academia, but also from water public authorities and private companies. There are also, other examples. This is just the most recent example that we have been working in our group, but there are other examples, like for example, another one was the planning of the most adequate wastewater treatment for small communities, which was a research project carried out in collaboration with the Catalan Water Agency in order to develop a decision support system to carry out this task. Another one was develop a decision support system to improve the operation and control of large wastewater treatment plants, which actually ended up into an spin-off from the University of Girona, which is working nowadays quite well. And there are a few others, but I think we don't have time to explain all of them. So just let me conclude with the most important message I wanted to give it here, is that we have to change the wastewater treatment concept to a new concept where, from one side, mass and energy can be recovered from wastewater, but most important, what I wanted to say is that we have to consider knowledge also as a key resource in order to improve decision-making in wastewater systems. And finally, just let me thank you, my workmates at the Technical University of Catalonia, Ulises and Miquel, and the University of Girona, mainly Ignasi and Manel. And for those of you who still want to know more about these projects and about these ideas, I would like to recommend you the reading of this brand new book. And thank you very much for your attention. ¿Sí?